And let's start. So, during this lecture, we will continue to consider second model of our course. It's difficult ground condition, and today we will start from considering the subsiding soils situation. By the way, right now I have a project of one really interesting building which is located on the subsiding soils, and I will explain the way how will we work with that building. So, but nevertheless, we have to start from this situation. Current situation with subsiding soils looks next way. So first of all, we have certain type of soils which is located under the building. And what is the specific situation with this soil? These soils are has this soil has certain properties, and these properties can be changed by with the presence of water. So, if these soils are in dry condition, everything is okay. We can build on them, we can use them, and everything will be okay with this building. When we have when we have additional water which can go from outside, from, for example, from rains or our leakages in the upper layers of the soil, the properties of those soils significantly reduces. Another type of impact on these soils, it can be from the underground waters. For example, if our building is located on the place of lake or old river, and the level of that old river moves up, it can make our dry soils, make it wet, and when additional water comes to our subsiding soils, it settles down. So there are two categories of subsiding soils. So first category, it is when it subsides with additional pressure with the presence of water, and the second category when it is settled down under its own weight. So even without additional weight from sorry, without additional pressure, it can settle down. So and we have also various effects of subsiding soils on the surface. It's vertical deformation, it's inclines, etc. And what should we do when we are building on the subsiding soil? So first of all, it's a correct vertical design. It's master plan. It's correct master plan design. And here is the problem with master plan. Sometimes when we are developing master plan, we cannot take into account that the incline of the surface is that it can lead to the collection of the water in such inner corners like this. So if we have incline which goes from upper marks till lower marks in this way, and if our L-shaped building is located in this way, and it can lead to the problem where our rain waters can be collected in this inner corner, and it will lead to the settlement of this ground, and it's a huge problem. It can lead to a huge problem for our building. So what can we do? We can rotate our building, and this type of location of this building will protect our building from collection of waters. So it will protect our building from subsiding effects. And here are the solution. Here is the solution for this situation. Also, we can locate additional elements which can protect our building from collection the water in this corner. Or we can make a ditch at the incline, so it will collect the water and it will this ditch will protect our building from collection of the water over here. So the water will be collected here and goes along our building. So next way for us to protect our building from subsidence is to support it on unsubsiding soil. So because regularly subsiding soils are the soils which are located on the depths not more than 10 meters from the surface. So, and if we know that, for example, on the depth 7 meters, 5 meters, or other value, other amount of meters, we have unsubsiding soils, so we can locate the foundation of our building on unsubsiding soils. Also, we can make same support of our foundation by using piles. Sometimes we can also make the substitution of the soil. So we can collect all the subsiding ground from this location and to replace it to the another side and move here and replace it with good and subsiding soils. It is also a good method, but it's really expensive. Also, we can use something like stamping method. It's like throwing a big heavy metal element on ground with a special crane which can move it up and throw it down. And when this metal heavy element will fall down on the ground, it will lead to the compaction of the ground, and the compaction will make our subsiding soil by it will make it unsubsiding. Why is that so? Because subsiding soil has empty pores, and when those pores are filled with the water, it impacts on the soil's properties, and it makes it leads to subsidence. So the situation is next when we are designing such in such situation we can or replace ground or protect our ground from subsidence or support our foundation on unsubsiding soils. But sometimes we can build in situation where it is impossible. And here is the example of the building which I am designing right now. It is impossible to make compaction of the ground because it is almost 8 meters of subsiding soil. So 8 meters, it's a really big amount of soil. It is impossible to make piles on that construction site because of certain conditions, and also it is impossible to replace the subsiding soil by an unsubsiding. And what should I do? What should I do in this situation? The only way that I have in this situation is to make next a solution because except of cutting through the thickness with piles or deep foundation or eliminating the properties of subsidence, we can also protect this ground from the water effect. But we have two sources of the water. So first source of the water is located underground, and we have to analyze: is it possible in this location to increase the level of underground water higher than it is right now? Sometimes it is possible, sometimes it's not. Because, for example, in Odessa, during the last 40 years, the level of underground water rises at 14 meters or something like that, because just after the war, the Second World War, the level of underground waters in Odessa was more than 10 meters, and right now most part of the center of our city has underground water on the level like 2 meters. Why is that so? It is connected with the underground pipes leakage. Also disconnected that the most part of our surface is covered with asphalt, and asphalt protects our soils from vaporizing of the water in the atmosphere. So it sort of like a conservation unit which leaves the water underground. So, and let's return to my situation. In my situation, in my construction site, I don't have a possibility of the underground water level moves up, because this construction site is located on the upper marks compared with the neighborhood construction site. So there is no underground water. First, second, all the pipes that are located near my building have to be protected with additional solutions. So, for example, when the leakage will arise at those pipes, it should be protected with certain signalization, which it's like special wires with connected I forgot how in English, датчик, data collector. It's not the data collector, датчик. It's simple word, but no sensor. Yeah, yeah, it's an alarm system, but this alarm system is connected with the sensors. And when the leakage in pipe will rise, the sensor will find this water and make an alarm signal to the service which looks for this building, and they will know that they have to do something with the leakage, and they will have to turn off the water. The water crane, so it will be the guarantee that we will protect my construction site from the underground waters from leakages in the pipe, in the pipes. And it is these two problems are connected with underground waters, but there is also rainwaters, and our experience shows that rainwaters in Odessa can be really strong, and we have to protect the building from rainwaters. And what should we do for to protect it? So first of all, and it's really important. First of all, it's to make a special cover. What kind of cover? It's a layer of compacted lime. And in my case, we have calculated the amount of lime which we have to compact near the foundation of my building. So here is the foundation, and this case it's 4 meters from the edge of foundation. And here we have, you can see this lime layer. It's lime which is compacted by heavy materials, and it protects the ground under my foundation from water leakages. So, and for example, if the water will be collected near this lime cover, it can go under my building. So it is here is the curvature of movement of the water, and in this case, with the distance 4 meter, it will be sufficient to protect our building from significant incline. So, and in this way, we have calculated that it is enough to make the lime cover on the distance 4 meters from my building. Because when we have calculated when without this cover, so this curvature was located in the middle of the foundation, and it led to significant inclines of the foundation. So here is the way how can we protect our building from subsidence. So first, it is to support the building on the unsubsiding soils, or use piles, or substitute the soils by with the unsubsiding, or we can use compaction method, or we can use coverage with a certain mm, lime. It's not maybe it is called lime lock, глиняный замок. Lime lock. So it locks the water from coming from upside under the foundation of our building. Uh, yeah, it's a problem for to translate, because Google Translate is like clay castle, but it's not the замок. It's not like a building замок, but it's like a lock which protects the enter of protects our building from enter of the water. So nevertheless, here are the four main solutions for the subsiding soils in Ukraine. Which are you? No, that's not only in Ukraine. These solutions are being used worldwide. So it was second difficult ground condition which I wanted to tell you about. So next difficult ground condition which we will analyze today is groundwater flooding. So when so previous problem which we have considered is connected with the specific properties of soils which uh, settles down with the presence of water, but not all the soils are subsiding soils. For example, sand soils are not subsiding soils, so the presence of water in sand soils will not lead to subsidence when we have only presence of water. When we have a water flow, it will lead to the problem. But when we have only presence of water, so when we have static water which is has a certain level which can go up or go down. For example, the sand near the sea can is almost 100% wet, and it will not lead to the subsidence. So but underground water can lead to certain problems for our building, because when we're talking about the flooding, it can lead to the increasing of the level of underground waters, and it can cause certain problems in our building. Sometimes you can find this situation on the foundation when you are when you are making foundation of your building, and the only way to from this in this situation to wait till it will drain into the lower layers of the ground, or to use pump to replace this water from the pit, from the underground, from the pit. And what should we do when we have the probability by the way, how can you define if you have groundwater flooding hazard on your construction site or you not? The only way to know to make a report of ground of soil condition report. So you have to hire an expert. They will make special analysis of soils, and after this analysis, you will know, you will get the info about the groundwater flooding hazard or subsiding soil hazard or something like that. So only this analysis will give you the info about how hazardous or not the hazardous or not the ground on your construction site. So next, what should we do when we are when we are erecting building or we designing building on the at the sites with the groundwater flooding hazard? So first of all, we have preventive measures. What's this? This is artificial of planning marks. So, for example, if you are designing building and the underground water is allocated on the depth 1 meter from the foundation of your building, and you need more, you can collect the ground from another sites and increase the level of your foundation on, for example, on additional meter. So an artificial increase will protect your building from this underground water flooding. Next, it's compaction of the soil. It's using of special equipment, special machines to compact the ground, and this compaction will protect you from this water level increasing. So next, it's ensuring proper drainage of surface water. So you will be able to protect your building from the rain waters when you will collect and drain the water underground. So next, it's careful execution of works during the construction and to protect the water networks and artificial water intensive facilities. Also, it is installation of waterproofing of foundation systems and deep structures and communication which are located underground. So you should use waterproofing. Also, it's arrangement of anti-filtration screens on the industrial drives and curtains around them. So it's like the solution which I described you when we were designing the building on subsiding soils. Next, it's construction of coastal or main intercepting and other types of drainage to prevent flooding. So drainage to protect from above ground income of water and compaction of ground or curtains or something like that to protect the building from underground level increasing or artificial increasing of planning marks if it's possible. It's not always possible. Next are the protection measures. It's arrangement of drainages and performance of external and internal waterproofing. And here this solution, for example, radial drainage. So when you have a certain construction site in the center, you're making what it's you're making well which will collect the water. Also, you are making underground bores where you will locate the perforated pipes, and those pipes will collect the underground water, lead it to the well, and in the well you will locate the pump, and the pump will replace this water from this well. So it's a widespread situation, and For example, if level of water is located over here, when you have made such kind of drainage, radial drainage, here is the curve of water table. So it reduce it from this one to this. Also, we can use line drainage. For example, you can dig a ditch around your building, make the drain layer, for example, with gravel or with perforated pipes. Sometimes we can use a layer of gravel, then locate perforated pipes in the geotextile. And also, the geotextile, it's like a fabric with small openings which can lead the water inside of the pipe, but to protect the pipe from income of small particles of soil. So gravel, pipe, and here we can like something like sand or something which can filtrate the water really well. So water goes on surface, drains through these layers, and goes from your construction site through this pipe, and then you will collect it where you want. Or, for example, you can lead it to the rain sewerage. If you know, there are two types of sewerage in our city, underground pipes. So first is civil sewerage. It's like canalizates all the canalization from regular building, and another rainfall sewerage, which is also located underground, and it collects only the water from rains, and the difference between them that regular civil sewerage is can is have certain levels of purification, and regular rainfall water system has less levels of purification, because rainwater is a clean water. It only collects oils and dust from the streets, so that is why it is much easier to clean it from various hazardous particles compared with the particles in the regular civil sewerage. So next solution, it's waterproofing drainages, vertical drainages, which also protects our building from collection of the water. And for example, if we don't have a drainage, the pressure of water will moves through the wall, and you will get the liquid inside of the building. But if you have make waterproofing with drainage, so waterproofing is like a gum film which protects from water pressure, and drainage layer will lead, like sand or something like that, will lead this water down, and it will go to this drainage pipe, and will go through the building to the rainfall drainage system. So it can be used like in like line drainage or planar drainage. There are various parts, various solutions. Not the best solution when you are collecting the water from outside, from inside of the building, but sometimes it's the only possible solution to protect our building from the outer groundwaters. Another type of soils also it is the solution like a radial drainage, which we have considered previously. Another type of drainage system also can show you. I can show you on this drawing. So here is a regular situation with the water table, and here we have high level of water, which impacts on the foundation of our building. But when we are using this drainage pipe, it collects water. And for example, here we have underground communications with leakages. When we making this drainage pipe, it will collect the water and it will reduce the level of underground water. But sometimes it is really difficult problem because, for example, if our building has this situation where our underground floor is located lower than the level of the water which is located near the river or lake. In that case, you should use like with radial drainage system. We can use well, which will collect the water, but we have to pump the water from this well all the way because level of the water near the building will be the same as near the river when you will stop pumping the water. I had the one strange situation. It was in 2018 when we were designing a new building in Luzanovka, and I've got the technical conditions from one regional. It's Управление инженерной защиты. I will translate it right now. Engineering Defense Directorate. It's from our city council, and they are giving you when you are designing new building, they are giving you technical conditions, and those technical conditions told me that I have to reduce the level of underground waters on more on at least 3 meters from the foundation of my building. And I tried to explain them that the foundation of my building is only on 40 centimeters higher than the level of the sea. So, and it's not impossible to make the protection of the ground under my building on the depth 3 meters because it's impossible to pump the sea on this level. But I still have this strange document, the really strange situation. But nevertheless, sometimes when we have a situation of a specific building which is located near the river or lake or something like that, such pumping solution can protect our building from the impact of this level of water. So it was the situation which is caused with the water flooding. Oh, by the way, there's also interesting situation. Sometimes the level of underground water increases significantly, and the situation which I found in the internet shows next situation that it was in autumn when the level of underground low water increased significantly, and this water filled this foundation and structural. So the engineers which were designing and directing this building, they decided to pump out the water from inside of this foundation. And the funniest thing was that this foundation has no piles. So when they have pumped the water from inside, it floated up. Yeah, it's like a bottle which floats on the surface of the sea. Yeah. So it's concrete, but the pressure of water was so big, so it make it float, and it's floated up this foundation. So that's why I want to show you the importance of the flooding. So next difficult ground condition which we will start to consider today, it's surface water flooding. So previous was the flooding which was caused by underground waters, but next level it is called surface water flooding, and it's can be divided on two various types. First is pluvial, it is caused with rains, and another is fluvial, it is caused with, for example, a river which goes from its boards. So and From its shores, sorry, and surface water flooding, and it's really I think you saw this situation in the movies, the TV. Surface water flooding can cause because the by Odessa rainfalls also, but it's a not regular situation. But there are situations when you design the building near the river, or somewhere when you can get big rainfalls, for example, on Balkovskaya Street or something like that, or somewhere on Peresik. So that is why we have to know what do we have to do with the pluvial or fluvial waters, which can lead to the open surface water when you can see the water. So underground water flooding, which we have considered previously, it's water that you can see because it is somewhere underground, maybe on not big marks, but you can see the water. But surface water flooding is the presence of groundwater which you can see. So, but one more time, there is pluvial, which caused with the rainfalls, and it can be caused, and fluvial, which can be with the level of the water in a lake or a river goes from the existing surrounding banks. And what preventive measures can we use? So the best solution when you are erecting building on the surface water flooding hazardous territories is to make an artificial increase on planning marks. So add additional sand layers or gravel layers. So the layers which can replace your building as high as it possible from the future surface water flooding. Also, compaction of the soils can also increase the probability of protection of your building from the surface water flooding. Also, it's ensuring the best solution is ensuring of proper drainage of surface water. So the best solution to protect your building from surface water is to ensure the good drainage. So it's to replace the water from your building if it's possible. Careful execution of work. So and also construction of various types of drainages. Uh, when we are talking about protection, it's embankment of territories from the river, reservoir, or other water body. So to use additional elements which can protect you for water income. Artificial increase of river, of relief, as we talked previously in preventive measures, and accumulation, regulation, and drainage of surface water and drainage from flooded, temporarily flooded, or irrigated areas and lowland distributed lands. Oh, next difficult ground condition we will start next lecture. It is called karst and submersion. It's a really important impact of water on certain soils, and it has specific results compared with the subsiding soils. So I will remind you in a few words the materials that we have considered today. So first of all, we are in the second model, and we are considering difficult ground conditions. First of all, we have previously analyzed undermined territories, undermined areas, and we already discussed the classification of undermined areas by deformations of the soils or according to the height of the bench on the surface above these underground mines. We can use rigid, ductile, or combined solutions of the building which we are designing above the undermined territories. And next difficult ground condition that we have considering today is subsiding soils, and its type of ground. It's a cohesive ground which, with the presence of water, leads to subsiding. And we have classification, we have measures when we are developing master plans to protect our building from collection of above ground water, a certain solution to replace the water from our foundation of our building. Next is to support our building on unsubsiding soils by deep foundation or piles or substitution of soils. Also, we can use curtains and protective measures, or we can make a compaction of ground, which also reduces its settlement subsidence properties. And next, which we have analyzed today, it was groundwater flooding. It's increasing of the marks of underground water level, and we should protect it by artificial increase of planning marks, drainages, water protection, etc. And last one that we have considered today, it's surface water flooding. There are two types: pluvial, which is connected with rain, and the fluvial, which connected with the river or other lakes or something like that. And the best solution is to make artificial increasing of planning marks, compaction, drainage, or and the other solutions which can protect our building from impact of above ground waters. Any question for today, colleagues? Any question? Or